Hello, and welcome to a video on evaluating a limit as x approaches a specific value of an expression numerically. Now here, we're looking at the limit as x approaches -2 of x cubed plus 8 over x plus 2. When we are doing this numerically, we want to set up a table for our x values and our outputs of our expression values, our f of x values. And when you do set up the values, you want to make sure that whatever your x is approaching, that number is in the middle of the table. Also, since I don't have a plus or minus after the -2, that means I'm approaching -2 from both sides. Now I want to make sure that you think about how to set up these values. Remember, on a number line, if we're looking at an x value of -2 and its placement on the number line, if 0 is to the far right here, then would come my -1 and then my -2 and then my -3. So as I'm approaching -2 from the left, on the left-hand side of -2, then I'm looking at values of like -2.1, -2.01, -2.001. So numbers that are close to -2, and then you want to have values that are getting closer and closer on that side. As I approach -2 from the right, we're looking at spans of numbers that are in the span from -1 to -2, but close to -2. And that's why I've put in the numbers -1.9, -1.99, and -1.999. So again, as I'm coming from the outside edges towards the -2, the values of x are getting closer and closer to it. Next step, what we do is we evaluate our function at each of these. So in this specific case, my function f of x is that expression that you're taking the limit of, x cubed plus 8 over x plus 2. So if I'm finding for my first x equal to -2.1, I'm evaluating f of -2.1. So that is my -2.1 cubed plus 8 over the -2.1 plus 2. Now when you run that through your calculator, you will see that you get a value of 12.61. And so you put that across from the f of x underneath the -2.1. Let's do the next one also. So f of -2.01, I have f of -2.01 is my -2.01 cubed plus 8 over the -2.01 plus 2. And from that you get 12.06. Now we're going to continue on with that process for each of these values. So if we put -2.001 in for the x's in the function, we would get an output of 12.006001. And then coming from further away from the -2, coming from the right towards -2, plugging -1.9 through the function, I'll get 11.41. Plugging -1.99 through the function, I get 11.9401. And then plugging -1.999 through the function, I get 11.994001. And the limit numerically then, we want to see as the x's get closer to -2 from both sides, what are the outputs getting closer to? I know right at -2, if I try to evaluate f of -2, we would get -2 cubed plus 8 over my -2 plus 2. But that gives me a 0 in the numerator and a 0 in the denominator, that indeterminate form. So I can't get this by just plugging in our values, but looking at what the outputs are getting closer and closer to as you come in at -2 from both the left and the right, they're getting closer and closer to 12. So therefore, my limit as x approaches -2 of that x cubed plus 8 over x plus 2 is equal to 12. And that is how you evaluate your limit numerically.